this video I am going to evaluate the most important problem from complex integration, and now I am going to evaluate integral z minus 3 by z square plus 2z plus 5 of dz, where c is modulus of z plus 1 minus I is equal to 2 using Cauchy's integral formula. Say what is the circle given here, that is z plus 1 minus I is equal to 2. So which means that, so I can write this in the form of z minus a. So this plus 1 in order to balance this one, and this is I, which is equal to 2. So this is minus into minus plus, and this is plus into minus again minus. So this is a circle equation with center. What is the center point here? With center minus 1 plus I, and radius here is 2. So what is the radius here? This is 2. So which means that the point here is on x-axis minus 1 and on y-axis this is plus 1. So with this point as center minus 1 1 and radius 2. So this is a circle equation, and let me show you this one. As you know, this is x-axis and this value is y-axis. See here, this is the origin point. This is 1, 2, 3. This is minus 1, minus 2, minus 3. And this is I, 2I, 3I. And this is minus I, minus 2I, minus 3I. So here the center point is minus 1, comma 1. See here, this is minus 1, comma 1. This value is minus 1, comma 1. And C, with the center C and making 2 units as radius. So I have drawn this circle, and this is the circle. So let us check whether the singular points are within this contour or not. So now we have to evaluate this integral, that is integral z minus 3 dz by, this is z square plus 2z plus 5, that is z square plus 2z plus 5. So this can be written as, this is z minus 3 dz by, so this can be written as, this is z square plus 2z, and 5 I am splitting it as 1 plus 4, as it can be written as, this is z minus 3 by a square plus 2ab plus b square. So this is z plus 1 whole square, and again 4 can be written as 2 square. So this can be written as z minus 3 by, this is z plus 1 whole square. I need minus here. So I am writing this is 2i whole square. See here I square, this is minus, minus of minus plus, in order to get the formula in the form of a square minus b square. As you know that a square minus b square is nothing but, see here a square minus b square is nothing but a plus b into this is a minus b. If I apply this formula, then this will be z minus 3 into dz by, this is a and this is b. So this is z plus 1 plus 2i, and this is z plus 1 minus 2i. So I need this in the form of z minus 3 times of z minus a. So z minus a. So this is minus 1 minus 2i. Got it? This is minus of minus plus 1. This is minus of minus plus 2i. And this can be written as z minus of. So this is minus 1 plus this is 2i. So this is minus of minus plus 1 and this is minus 2i. So I transform this question in the form of this. And now see, the singular points here are, so what are the singular points here? Z minus Z naught. So the first point here Z naught is minus 1 minus 2i, and the second point here is minus 1 plus 2i. So which means that x-axis is minus 1 and y-axis is minus 2. Here x-axis is minus 1 and this is positive 2. So let us check whether these 2 points lie within or outside the contour C. See here, the singular point Z naught is equal to, so the points here are minus 1 minus 2, minus 1 minus 2, and here the second point here is minus 1 plus 2. So these are the 2 singular points, and let us see. So this is a circle equation with center minus 1 1 and radius 2. So with the radius 2, this is minus 1, minus 2. Where is minus 1 here? This is minus 1. And here this is minus 2. So here this is minus 2. And the next one is minus 1 plus 2. So this is minus 1 and this value is plus 2. If you observe this one, so this value is minus 1, 2 is inside C, whereas minus 1, minus 2 is outside the contour C. So only for this point Z0, Cauchy's integral theorem is applied, whereas for the point minus 1, minus 2, so for both the minus, that is minus 1, minus 2i, Cauchy's integral theorem is not applicable as it is outside the circle C. So be very careful. See here, this is the point which you have to note. This is minus 1, x-axis is minus 1 and y-axis is minus 2. As it is outside the circle C, Cauchy's integral formula is not applied, whereas for this point it is applied. So I am transforming this question in the form of, see here, so this is the point. So this is the integral, that is z minus 3 dz by, see here, this is z minus 1 minus 2i into, the next thing is z minus of minus 1 plus 2i. So here this is minus 1 minus 2. So minus 1 minus 2 is outside C. So this is outside C. So I am writing this in the form of z minus 3 by, I am taking this to the numerator. See how I am taking, this is z minus of minus plus 1, this is plus 2i divided by. So this whole thing I am considering this as f of z, and this one as this point, that is minus 1 plus 2. This is minus 1 plus 2 is within C. Now I will apply Cauchy's integral formula at this point. See, what is the Cauchy's integral formula? According to the Cauchy's integral formula, so we have f of a is equal to integral 1 by 2 pi I. This is f of z dz by, the value here is z minus a. So for this formula, see here, this integral is needed. F of z dz by z minus a can be written as, I am sending this 2 pi I to other side. So I am transforming this formula according to my convenience. This is Cauchy's integral formula. Now I have to apply this integral on this. See, after applying, so which integral is needed? That is z minus 3 by, this is z plus 1 plus 2i. That is z plus 1 plus 2i into dz by, this is z minus of minus 1 plus 2i. So here when we compare this to, what is f of z? So f of z value is nothing but z minus 3 by, this is z plus 1 plus 2i. And see what is a value. So a is very clear as minus 1 plus 2i. So if I substitute the same thing in this formula, that is 2 pi I into f of minus 1 plus 2i. So f of z is this value, and if I substitute z as a, and see, this will be 2 pi I times of, in place of z as minus 1 plus 2i, this is minus 3 by, as we have f of z value is z minus 3 by z plus 1 plus 2i, and we need f of a. So in place of z I am writing minus 1 plus 2i plus 1 plus 2i. See here, this will be 2 pi I times of, this is 2 pi minus 4, and this value is 4i. So I can cancel these two. So if I cancel these two, so I can cancel, and I can cancel this for 2 times. This is pi by 2 times of, if I take 2 common, this is I minus 2. So the value here is pi times of, this is I minus 2. So this is how we have to solve, and this is so simple if you follow these steps. First of all, what is given? The circle, contour circle is given with center minus 1, 1 and radius 2. And this is the circle. So with radius 2 and center minus 1 comma 1. And now we have to evaluate this integral after splitting. So this is of the form a plus b into a minus b. So minus 1 minus 2 is one singular point and minus 1 plus 2 is the another singular point. If I check here, minus 1 minus 2 is outside. So if it's outside, I am transforming this one as f of z. So I have taken this one to the numerator and this acts as f of z and this is a. So when we compare, this is f of z and this value is a. And now if I substitute in place of f of z as minus 1 plus 2i and after calculating, and this is the final answer. This is how we have to solve. Thank you so much for watching and staying till the end. And this is a very clear picture to determine whether it is inside or outside or on the contour. Thank you so much for watching.